All right, so from lines to linear inequalities. Yes, inequalities again. And because I couldn't find anything cute that had to do with this, I brought SpongeBob in. Because math. And SpongeBob, I think SpongeBob is one of those things that makes most people happy. But anyway, let's talk about linear inequalities. A linear inequality is made by replacing the equals sign in a linear equation with an inequality symbol. So instead of having y equals x minus 3, you got y is greater than, less than, greater than or equal to, less than or equal to. A solution to a linear inequality is an ordered pair that makes the inequality true. So if I have this inequality, y is greater than x minus 3, to tell if a point is true, you're going to substitute the x and the y values in for x and y, simplify, and decide whether or not we get a true statement here. The check mark indicates that for the point 1, 2, this inequality is indeed true. So 1, 2 is a solution for that inequality. And over here, negative 3, negative 7, but we plug that in, we get a false statement. Negative 7 is not greater than negative 6, hence the x here. And that means that point is not a solution of that particular linear inequality. Now, we don't have a visual yet, and we will in a minute, but you can do this visually. Right now, we're just doing this algebraically. So try this problem at the bottom. If you think you caught on fast, then pause it, and then you can continue it for my explanation and work. Is 3, 6 a solution of y is less than or equal to 2/3 x plus 4? Y is less than or equal to 2/3 x plus 4. So I'm plugging in 6 for y and 3 for x. And the idea here is that we don't know. So I'm going to put a little question mark. I don't know. Is it true or not? My question mark got really messy. Anyway, math time. So let's multiply. 2/3 of 3, that's 2 because the 3's cancel. So I have 2 plus 4. Is 6 less than or equal to 2 plus 4? Well, it is because it's equal to. So that means that the point 3, 6 is a solution. Oh, that's not how you spell solution. In case you were wondering. Is a solution to our inequality. But that's great to plug in, but it would be great if we could also have a visual. So let's look at how we graph these inequalities. The graph of a linear inequality consists of two parts, a line that is either broken or solid, and shading on one side of the line or the other. That graph is called a half plane. A plane, remember, is a flat surface that extends out in every direction. In geometry, you tend to draw them as like parallelograms, where we're saying that this could keep going in every direction. So it's like it's a piece of paper, a flat surface, but it keeps going in every direction. The half plane is half of the coordinate plane. And it doesn't matter where you put the line, you automatically get half of the coordinate plane. It's a complicated concept to explain because it doesn't look like half and half. This shaded side and this, both of them clearly look bigger than the other side. But if I was to extend it out in all directions, as soon as you put any linear inequality on a plane, you have a half plane on each side of it. So let's talk about the line that's either broken or solid and the shading. All right, on this inequality, because its y is greater than 3/2 x minus 1, you have a broken line. A dashed or broken line is used for inequalities with greater than or less than. If you have, like this inequality, the or equal to symbol, you get a solid line. So they say dashed for broken, and then, of course, solid. I said solid for solid. In terms of the shading on one side or the other, if you have a greater than, you're going to shade generally above the line. Now, this can be a little difficult to figure out. So one way to do that figuring, one way to decide which way am I supposed to shade this, is to pick a point that's on one side or the other. The most common one we'll pick is the origin. Most of these lines are going to either go on one or the other side of the origin. So 0, 0 is a great number to plug in, plus 0 is easy to use in math. So I can tell here that 0, 0 is supposed to be shaded when I plug in 0 for y and 0 for x, I get a true statement. 2/3 of 0 is 0, so I get 0 is less than 0 minus 1. 0 is less than -1, so it is shaded correctly because it includes, in this shaded region here, it includes the 0, 0. That's the same for this one, but let me go ahead and pick a point that didn't fit for this one. This one was less than, so we generally shade below the line. Again, it's not always easy to figure out which one's above and which one's below. So let's look at the point 1, 1 for this inequality. Well, is 1 less than or equal to -3/2 times 1 plus 1? -3/2 plus 1 is -1/2. Is 1 less than or equal to -1/2? No, it is not. 1 is definitely bigger than -1/2. You can tell very simply because -1/2 is negative, and a positive is always bigger than a negative. So this one is shaded in the correct direction. This way, not this way, because 1, 1 definitely would not be included in the solution set. So again, to recap, the graph of a linear inequality consists of two parts. The line that's either broken or dashed or solid, and then the shading on one side of the line or the other. All right, let's try one, and then we'll test out some points. So we're going to graph the line y equals -2x plus 5 first. We're going to graph the line y equals by putting points on the coordinate plane. It's got a y-intercept of 5, so we'll go ahead and put a point there. It's got a slope of -2. So slope of -2, remember we can write as -2 over 1 or 2 over -1. If I use -2 over 1, I'm going to do rise of 2, run of 1, or rise of -2, excuse me, so down 2, run of +1, so our point goes right here. Run of 2, -2, excuse me, rise of -2, run of 1, point. 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 Arrow there. If I was going the other direction, I'd only have one space. So there you go. So there's the line portion of it. Don't draw it yet, though, because this is not a solid line. It can be a real pain in the butt to draw the line and then have to go back and change it. If you're on paper and pencil, it's fine if you're using a pencil, but of course pen. And when you use like Notability, you'd have to go back and erase the individual line. It won't erase just little bits of it. You have to draw the whole thing again. So the reason I do the points, I plot the points here, the dots, is that now I can easily make this a broken line. All I have to do is not connect everything. So there we go. There's the line portion of y is greater than -2x plus 5. Remember to look at your slope, negative, downhill, your y-intercept 5. Make sure you're doing okay so far at this point. Now you got to decide which way to shade. Now the fact that it is a greater than says that we shade up. Now it's not too hard to see up here. It's this side, up above the line. Again, check and see with a simple point whether or not it fits. Again, 0, 0 is an excellent point to choose. Now, if I shaded this correctly, 0, 0 should make this inequality false. So let's see. 0, oh, gotta get my pen tool. 0 is greater than -2 times 0, which is 0 plus 5. Definitely not true. 0, 0 is not included. I know I did that part right. Now let's find out if these points are solutions using a visual, using just the graph. So use just the graph over here. So -4, 2. -4, 2. It is not in the shaded region. Therefore, no. This is not a solution to this particular inequality. What about 0, 5? 0, 5. Now don't jump the gun. Oh, well, there's a dot there, so it must be. But this is not or equal to. The points that are on this actual line do not make the inequality true. They do not. Let's prove it by actually plugging in our point 0, 5 instead of just trusting our graph. Remember to plug in the 5 for y and the 0 for x. 0 times 2, oh, -2, is still 0. So we get 5 is greater than 5, which is false. So this is not a solution to the inequality. 5 is greater than or equal to 5 would work, but it's 5 is greater than 5, and that's not true. Last one is 6, -3. So 6, -3 clearly is in the shaded region. If you went through and plugged it in, yes, that one would be a solution to our inequality. All right, let's keep going. All right, here's another one to graph. I'd like you to try this one on your own, so pause it, please. Give yourself a challenge. You can figure it out. All right, so I'm going to go ahead and do it too. We are graphing the line y equals 1/3 x minus 4. So we're graphing a y-intercept at -4 and a slope of 1/3. And to recap from graphing lines, we can graph a slope of +1 over +3 or -1 over -3. So from this y-intercept, I could go up 1, right 3, plot a point. I can then go up 1, right 3 again and plot a point. Or I could go down 1 and left 3, down 1 and left 3, and plot those 2 points. This time, there's my arrows, it's a or equal to symbol up here, which we learned is a solid line. Ooh, would help if I was a little neater there. Let's try that again. Okay. Sometimes it gets a little messy on the iPad. I apologize. All right, solid line. Now I got to do the shading part. Again, I could plug in 0, 0. This is a lot easier, though, to think about my less than being below the line. One thing I want you to notice about all of these that we graphed so far, they're in slope-intercept form. They're solved for y. That is the best thing to do with an inequality before you try to graph it, is to solve for y. All right, one more slide. Horizontal and vertical lines. Just like the regular lines, the line portion is the same. Your y equals some number. Switch colors again, hold on. Your y equals some number is your horizontal line, and your x equals some number is your vertical line. So we have a y is less than 4, all right? So we graph a horizontal line where y is 4. And again, I'm going to just plot points. Got lazy there, I just kind of made it ... because I know it's horizontal. Now it's broken because it's not or equal to. And just like we said before, less than, we shade down. For x, so we'll underline that over here in blue. For the other one, let's use green. For x, it's a little different. We know that's a vertical line. So we want all of the points where x equals -2. This is an or equal to, so this is a solid line. Gosh, that got messy real fast. A solid line at -2. Solid line, okay? And it's greater than or equal to. Greater than or equal to, we shade to the right, because that's where the x values are greater than -2. So you can't think up and down with a vertical line, because you can't shade above a vertical line or below a vertical line. You have to think what's greater and less in terms of the x value there. And that's all you got for linear inequalities. I'm going to call it quits for this video. That's what you need to be able to do. We'll be graphing some when you come to class. All right, see you in class.